Testing, testing. Can you hear me? Hi. Thanks for the reminder that I was muted. I haven't set up my stream correctly yet, but hopefully it's better now. Can you hear me now? Thank you. Great. So I guess I'll just talk a bit more about what I was trying to say. My plan is to do some Division 2 problems. Oh, my audio is a bit low. Okay, how's this? Is this better? I think I turned it up to max this time. Testing. Can you hear me? Testing. Testing, testing. Okay. Awesome, awesome. Thanks so much for letting me know. Here's Code Forces. So my plan for today's stream is to do something like a virtual Div 2 contest, but with the goal of solving all the problems and writing a clear explanation for them before typing anything, and then implementing it as fast as possible without bugs. So let me write that down somewhere. I'll share my my terminal. Close my tabs. iTerm. Okay, and let me resize my windows. Okay, Code Forces, maybe a bit bigger. Okay, so plan for the stream. Do a Division 2. Oh yeah, everyone in the chat, I will be reading chat, so hi everyone. Thanks for tuning in. I'm just giving a brief overview of kind of what my plan is for today's stream. And I will be reading the chat. Yeah, road to LGM. That's what we're doing. This will get me to LGM hopefully. Solve problems and explain solution. In writing, take notes. And then, okay, let me say this for each problem. Solve it, write solution notes, write implementation notes. Yeah, everyone watching this stream, you're lucky because you will get to LGM as well just by watching. Time, set a timer and see how fast I can write the code after having planned out the implementation. And goal is to develop habits of pre-planning implementation. Yeah, chat moderators. I'll just do that for now. I don't really have. I don't think I have so many viewers that I would need a moderator yet. Maybe one day. But yeah, so the strategy is I'm going to try to explain every problem and fully solve it and plan out the implementation before typing anything. And then when I do go to type it, I'll try to do it as fast as possible without any bugs. And hopefully that also yields a higher rate of success and total solve time. So yeah, let's pick a Div 2 contest that I haven't done yet. Let me log in. What's my password? I don't really remember. Testing all of these. Okay, cool. So I'm in. What? So I have some requests in the chat. Feynman 67684. I don't think I've done that one, have I? Oh no, I've done the corresponding div 1, so maybe that won't be too exciting. We can do the A and B for warm up, I guess, but I do want to do a round I haven't touched yet. Okay. So, sure. Let's do warm up. Div 2, 684 div 2, A and B. Yeah, and then main round suggestions in the chat. So yeah, let's do 684 div 2. I'll virtual just to A and B. I'll have it start in a minute. And then I'll set up my template. Cool. And yeah, I'll start typing up notes here. And let's also get a stopwatch, because this will be useful for timing our actual implementation. Okay, so we're getting started in 8 minutes. I'm not audible anymore. Oh no, is that true? Testing. Testing. Okay, great. So yeah, let's open up problems A and B. We'll just try to get through these quickly. And let's see, you're given 4 integers and a string. You can change any character. A change costs H. Then you buy the string. And the cost of buying 0 is C0, 1 is C1. Find the minimum cost. Okay, so my notes, all cars are independent of each other. And then there's a simple formula for each character. 0 means you can either pay C0 is the first choice, or you can pay C1 plus H. And 1 is similar. You can either pay C1 or C0 plus H. Because the trick of this problem is, well, you're never going to change a single character more than once. You either change it 0 times or 1 time. So there's exactly 2 options to consider. And since we're trying to minimize the total cost, we're going to take the minimum of the 2 options. So now that we have this written down, the implementation strategy, planning, count number of ones, from zeros, from ones. Compute cost of 0 and 1, so cost 0, cost 1. And then return num0 times cost 0 plus num1 times cost 1. Because limits are small, answer fits into 32, because it's at most 1000 times H. Okay, so now that we have this plan, let's go ahead and switch over to coding. So stream, let me save this file. Let's see how I should, I'll just type in this bottom half. As soon as I click start, I'm gonna try to get it submitted and accept it as fast as I can, but also without bugs. So ready, set. Actually, should I have this in a separate window? Yeah, I'll have this in a separate window. Just 1 sec. So I'll add a new window capture. stopwatch. And I'll put it over here, where it probably won't obscure anything. All right, ready, steady, go. Wait a sec. Oh, the string. And then we'll test it because we don't want to get it wrong. 352, blah, blah, blah. Submit it. Choose file. We'll click stop because I probably got it right. Oh no, my face is blocking the editor. Yeah, let me fix that. Maybe I can swap. I'll put my face on the left because code forces is probably not as important. Okay, I got accepted. It took about 1 minute and 7 seconds. So that's, all right. I typed 14 lines, so that's an average of like 5 seconds per line. I did kind of stumble because I forgot that I was reading in a string and not an array of integers. Eminem raps, thank you. Coming in, look for copper and you found gold. And yeah, let me walk through my solution a bit, just in case anyone is curious. It's pretty straightforward. I read in the input, there's 4 integers, and then I read in the string. And then I count number of zeros and ones by iterating through every character of the string. And then I compute the costs by taking the minimum of the 2 choices. Then, as I promised, I multiply the numbers together and I add them together and I print it out. So yeah, pretty par for the course for div 2a. So let's move on to div 2b. Back to my notes. And I'll write my notes here as I read the problem. Okay, so it's about sum of medians. So the median is the one, the right one is the one you take if it's an even length array. No, that's not right. It's one on the left. Okay. 1, 2, 3, 4, 5, 6 is the, yep. So you're given 2 non-decreasing, so it's getting bigger. And it's nk. K arrays of size n, such that each number belongs to exactly 1 array. You want the sum of all k arrays, sum of the medians, to be maximum possible. Okay. Okay. I'm not sure how to do this. I think you want I think you basically want your arrays to be kind of sorted. So there will be, okay, so let k equals a plus b. No, let n equals a plus b for convenience, where a and b are close together. The k times a smallest numbers will form the smallest a numbers of each of the k arrays. The k times a largest numbers will form the right half. Lost Coder 16, hello, welcome to the stream. So, okay, given that I've divided my numbers into the things that will make up the left half and the right half, because this is going to be optimal, which k numbers, now the question is, which k of the k times b will be the medians? So this will be for each array, the minimum of those numbers. I don't think you can do much better than just sorting them. Can't do better than just taking 0, b, 2b, etc. So let's call this b equals. So to be clear, I'm claiming that you can't do better than this. You can't do better because there's an argument. You can compare any list of medians sorted w, or let's call this like ants equals so yeah, I'm proving that this is k minus 1b. Any other list of medians, ants prime equals, let's call it like ants prime 0, ants prime 1. There's this proof, like the largest element of ants prime must be less than at least b minus 1 elements. The second largest element of ants prime must be less than at least b minus 1 plus b elements. So let's call it 2b minus 1. And in general, the ith largest element will be I times b minus 1 elements. And in fact, this means it's less than or equal to b sub largest element of ants. So yeah, this is my short proof. I think it's rigorous. It's basically claiming that I have this optimal solution ants, which you attain by taking every k, every b element of the k times b largest numbers, and that any other potential arrangement of the medians will, not be better than the one I claim as the answer, because there's this property that if you sort the medians, that kind of defines like some sort of rectangle. Like if you are the third largest median in your array of size n, that means there's 3 times like n over 2 elements that must be larger than you. And that basically is what we can already achieve just by taking every k element. Okay, as per GPU, how long will the stream go? I haven't planned exactly how long it'll go, at least an hour, probably longer. I'm trying to do a lot of streaming this year. That's one of my New Year's resolutions, actually. So ideally, I go for an hour or 2. I'm going to turn on the light real quick. Okay. So yeah, an hour or 2, just whenever I get tired, basically. Yeah, I think it's time to implement this. So any implementation notes? So read in the length. Oh, hey Hurdler, thanks for stopping by. Nice to see you. Elements, sort, and then take the, what exactly, which positions is it? Let's just say offset equals k times a, where a equals n over 2. And then select v off plus, okay, v off plus I times b for I equals 0 through k. And I think that will be enough. Okay, so there's our implementation notes. I wrote down the key formulas, which is a equals n over 2, b equals n minus a. And this should be enough to like kind of let us type out the program all in one breath, basically, without losing focus and having to do math, because all the math is already done. And that's like a useful strategy, I'd say, when the implementation gets more hairy and there's a lot of control flow and logic to keep track of. It's nice to not have to do math at the same time. So I'm going to shoot for 1 minute of implementation time again here. I'm actually going to cheat this time and pre-download the sample case. And ready, set, go. It's all wrong. I want the maximum. Wait, this is, oh no, it's all wrong. It's because I messed up. The medians, let's print out the answer I'm getting. 0, 34. Yeah, this is not going as well as I wanted it to. Let's try to debug. Yeah, I'm gonna have to debug this a bit. Let's print out both the answer and the sorted array. So what went wrong with my reasoning? I'm printing out 64, 67, 69, 78 because I'm taking the rightmost when it's even, and in fact all of these are even, which is why my answers are all wrong. N, comma K. Yeah, the only one that's not even is 234, and my answer is correct for 234. Okay, so basically what went wrong is, well, I think my A is actually too big, so this is what I needed to do. And this will work. And yeah, I should have done more math during the planning phase, but that's okay. I still got it in 242, assuming this passes. So yeah. Oh, it didn't pass. I forgot to think about longs probably. Yeah, these numbers get quite large, so let's change that to LL, resubmit. Okay, so not doing very well with my goal of not getting anything wrong. So let's say the final time here is 2. Let's just call it 3 minutes because I have to resubmit plus 1 wrong answer, test 2. And let's do a retrospective. Forgot to think about int versus long, and off by 1 when computing A. Yeah, should have thought about it more. Writing down the formula. So yeah, the error occurred during the planning phase, not the implementation phase, because I'm expected to have thought through all of this during the planning phase so that I don't have to think about it during implementation. So that's where it went wrong. Planning phase. Okay, so that's a good warm-up. Now let's do something for real where we virtual a round I haven't seen. I'm going to read through the chat and see if there are any suggestions. Div 2 educational, round 670. Yeah, let's see if I've done 670 first. Okay, I haven't done round 670. Let's also look for educational rounds. These can get kind of hard. Yeah, there's a few that I haven't done at all, so I could do one of these. Let me know if you have any preferences in the chat. Yeah, div 2 670. I'll probably do this one. I'm going to take a 1 minute break before this round starts to get water. And I'll just register for the virtual now, I guess. All right. So we're doing the main round now. Again, we're going to do the same format where I time myself only for the implementation part. This helps me kind of optimize my pre-planning phase and also kind of take the pressure off of me while I explain the thought process and solution, so I can make this kind of both instructive and also like good practice for myself. At the same time, I'm going to try to get a good result, so I'll set a goal here. Main round is 670 div 2. Goal is top 5 with commentary. I'm probably not going to hit it, excluding, let's say, other unofficial participants. So that makes it much easier. I just have to be in the top 5 among the div 2 people. All right, let's start with problem A. I think strategically it would be better to start with problem E if I'm going to be talking through all the problems, but whatever. Subset Mex. I'll write the titles. And let's also make a new directory. Okay, so given a set of integers, okay, multi-set, you have to split it into 2 subsets, maximizing the value of max. Max, smallest non-negative integer. Okay, so I think the solution here is to greedily just make the first max as large as possible, because there's no point in saving, you know, any numbers for the second set. You can always just say the first set you make is as large as possible, and then there's only one way to make it large. It's to put one of every number from 0 to k, however large k can get. So you do that for the first one. You greedily construct solution. Greedily maximize the max of the first array A, and then by taking one of each of 0, 1, I, until you can't take I plus 1. And then B is whatever remains. Compute the max. And then answer is max A plus max B. So implementation strategy, there's some notes here that I think there's some cool stuff that I'm gonna do here, is write a function, max, and use it to find the answer. Max of A is just I plus 1, but since we need to write max anyway, might as well call it twice. And I think this is like actually the right, or like a small way to save a bit of mental energy. Like you don't have to double check that your computation of max A is correct, because like you don't have to rely on max A equaling I plus 1. You need to get your max function correct. You might as well use it twice if you're going to go through the trouble of making it correct. And use multiset dot erase to yield B after constructing A, and use multiset. I guess A will also be multiset to match the function signature of your max function. It expects a multiset, even though all elements should be distinct. Constructing A will look like a while loop. Iterate I starting from 0, and keep erase inserting I from B to A, and as long as B contains I. So that is my implementation plan. I'm going to read in all the elements into a multiset called B, and then starting from 0 and incrementing by 1 every time, I'm going to keep erasing from B this, let's call I, as long as I is present in B, and then inserting it into A, and then I'm going to output the answer. And I can also use, this will help me debug really well, because I'm directly, like, according to the problem set statement, constructing these two subsets A and B, so I can just print them out if I get confused, for example. So, getting ready to code. I'm cheating a bit because I have this test case number reading while loop, but I'll give myself that. I think I need all the help I can get. So ready, set, go. Okay, first compile, 5340, it worked. Submitting. I'm around 1 minute if this passes. 112. Okay, I accidentally clicked start again, but I'm pretty sure it said 112. This is actually exactly the same. Oh, it's not exactly the same, but it's about the same as it took for the other div2a. So at least I see some consistency there. But yeah, let's review a bit of the implementation details that I kind of came up with on the fly, honestly. Implementing Mex, I did not plan ahead, but it's, how hard can that be? I didn't think about how I would check membership of a multi-set. Like, in my planning, I talked about erase and insert, right? But I did not talk about find or count. I chose to use count because it's easier to use it as a condition. I don't need to find it. I just need to know how many there are, or more particularly if there's at least one. But that's something I came up with on the fly. It didn't take that long because I've used a lot of multi-sets before. And then everything else is just as I planned. I erased from B. I initialized B to all of the things, and I erased from it gradually, and then I used Mex to compute the answer. GT matters. That's cool submitting with the terminal itself. How it works, it's not automated. All it does is it copies my file to the desktop, so I don't have to browse in Chrome. Choose file, it doesn't show up on the stream, but I am still double clicking the file myself. So it doesn't actually do it for me. I'm the one manually clicking things. Yeah. Let me know if there's any other questions. Happy to talk about this problem a bit more. But yeah, it went pretty well. Happy New Year to me. I'm going to move on to problem B if there's no questions. Yeah, I didn't read through the samples because I was confident I understood the problem statement correctly. Maximum product. Okay. So you want IJKLT in some order. So wouldn't you just take the maximum 5 numbers? And then, oh, no, because of negative numbers. So either take 0, 2, 4, or 5 negative numbers. And for each of those cases, you maximize accordingly. So let's put this in the doc. Maximum product. Either take 0, 2, 4, or 5 negative numbers. Why not 1 or 3? If you could take 1, actually no, that's a good question. You could consider taking 1, because n might just be 5 or something. Let's assume n is at least 6. Yeah. If n equals 5, there's only one possibility. Trivial. If n is at least 6, my claim is your optimal solution takes 0, 2, 4, or 5. Why not 1 or 3? Because the last number, okay, there's at least one number you haven't taken. If it's negative, swap with positive, and now you have a positive product. Likewise, if it's positive, swap with negative to obtain positive product. So that's my proof for why you should never take 1 or 3 negative numbers if you have at least n equals 6. Oh, why tree? Do you deliberately go through this planning process during the contest and you're just practicing that right now? Yes, in fact, I try to plan my code ahead of time because I'm going to have to answer some questions like how am I implementing this eventually. I'd rather have it ready ahead of time so that I don't have to be interrupted in the middle of my coding. I want to have a clear picture of my code before I start typing it, just to avoid any possibility of me messing up. Trying to come up with things on the fly, I think, is highly prone to error. obviously, like, I could probably do it on the fly. It wouldn't be the end of the world, but I think doing it ahead of time does reduce the chance of error, as long as I do it, like, diligently ahead of time. I do think of all the cases. And yeah, this helps me during contests, I'd say. It reduces the amount of, like, using the backspace key, for example. I rarely have to, like, delete stuff and rewrite it if I do it this way and think through it all ahead of time. Because I know when I was like less experienced as a competitor, I would often just have like maybe 80% of a solution and just start typing. It's more like 50% of a solution. I would just start typing and then midway through realize, oh shit, I forgot about this case, and then maybe end up deleting a lot of my code and having to go back to the drawing board. So I really want to avoid that case. I want to come up with any edge cases ahead of time instead of just trusting that I'll figure it out. So yeah, I proved that if n is at least 6, we only need to consider 0, 2, 4, or 5. And then I think in each case, the solution is fairly obvious. For 0, 2, and 4, always take the suffix of odds and evens. So, sorry, pause and negative. Let's call it, yeah, P and, or V pause, and V neg. So let's let V pause and V neg be arrays sorted by magnitude, increasing. So yeah, we have V pause negative. For 5, since our product is going to end up being negative in sign, we want to minimize the magnitude. So always take the prefix of just V neg. And then don't have to special case 0, just treat it as pause or neg, doesn't matter. Because all the inequalities that we leverage in our proof of, positive and negative or suffix and prefix, they don't really care whether your number is 0 or not. It still works. Okay, and implementation notes. Need long. You're multiplying 3e3 5 times equals 27e15. Okay, obviously it's going to fit in the long. Code forces never really makes you do anything more than that, but just to make sure. What else is there? Not much. Gonna write a lot of things like ants equals max, ants canned. Oh, and initialize ants to the 5 case. Yeah, so do the 5 case first. Okay, and I think that's all I have to do. Let's get started. Timer, ready, set, go. Okay, a suffix of neg. So, honestly, this should be prefix, so let's reverse the pause one instead. So, pause, neg. So now we do pause. Okay, I think this works. Negative 120, 12, 0, 9, 4, 5. My vector is way too big. What happened? I forgot to read in the vector. It's because I was thinking ahead. I was thinking about doing the initialization. I should have thought about that more ahead of time. Okay. Negative 120, 12, 0, something else. Okay, so I got that case wrong. It's because I have to skip when out of bounds. Okay, I'm gonna prepare the submission. Oh, what the? My last one is still way off. In theory, checking a comma 4 comma 1 should have worked. Oh, it's because I want greater than. And now I'm gonna submit for real. Stop the clock. 3:14. Not great. Assuming I pass. Oh, I'm not even passing it. Oh my god, I'm not. I forgot about long sim. No, I didn't. Start the clock again. This is not going according to plan. For all my talk about planning ahead and not making mistakes, I'm making a lot of mistakes. So what's going on? Am I doing my sorting incorrectly? So I'm doing pauses sorted in descending order, nega sorting in ascending order. So I want prefixes. Yeah, I thought I got everything correct. I thought I understood the problem correctly, but I guess not. Yeah, this is it's kind of strange. I didn't think I would get it wrong. Yeah, I don't know what the issue is here. This is not great. I am passing the samples, but let's just print a bunch of stuff out, make sure it matches what we expect. Pause is descending order, neg is descending order, pause is a bunch of zeros, neg is not. I'm pretty sure my logic regarding negative numbers is correct. Like, oh no, it's not. There is a case when you'd want 3 negative numbers and 2 positive numbers. No, I don't think there is. Because you can always make a positive or non-negative product. How can I watch the stream from start? I am Faraz. I'll post this to YouTube after I'm done, so then you'll be able to watch from start. I don't think there is a way to watch from start right now, though. Yeah, sorry about that. Okay, so I just checked my logic around. Just kidding. I got it wrong. Yeah, I just checked my logic about not checking for 1 or 3 negatives. I think it's correct. I really do. I really do. Oh wait, but if you have no negatives... Oh, I forgot to check the no negative case. Jesus. So let's reverse and go 5, 0. Okay, that was kind of embarrassing. I totally thought I checked this in this case, but I didn't. So that's on me. That's an implementation problem. I definitely said I needed to check that in planning. Okay, so 728. Well, at least I found my bug. It was that I forgot to check the all negative case. For some reason, I thought I was doing that by just multiplying the first 5 numbers, but turns out that it's not true. I definitely wrote that it's 0, 2, 4, or 5 because I was thinking about the all negative case. So during planning, I made no false statements, but translating it to code, I brain farted. My implementation notes did not have anything to do with the 5 case, except that I would do it first. I ended up deciding not to do the 5 case first, and that is on me. I thought I could be clever and just initialize it this way, but then I forgot to do the 5 case at all because I thought this was a replacement for that. So yeah, it's very easy to make that kind of mistake if you're, I guess, not being very careful. So, lesson learned. If you're gonna deviate from implementation plan, make sure you're not leaving something out. Maybe just don't deviate at all, because it's risky. So yeah, better to just have a good plan from the start than to try to optimize it in the middle. I think that's generally true, unless like if you do deviate, you should like just be very careful about what you're doing. All right, let's go on to problem C, link cut centroids. Problem C on div 2 usually gets, at the level of difficulty where you actually do derive, like you actually do gain a lot of value from doing this planning. So this is where my advantage comes, where planning actually helps more. All right, let's read the problem. Only one centroid. Okay, so it's like not very symmetric. So he can cut one edge and add one edge, preserving the tree structure such that the resulting centroid is unique. That's a very interesting problem statement. It's always possible, as expected. Okay, very interesting problem statement. How do you do this? It's a constructive problem. Let's take notes. So, summarizing what we've learned from reading the statement problem, constructive problem statement. Let's look at the bounds. N is 10 to the 5. And let's just think about the problem a bit. So let's recall standard centroid finding algorithm. Start at a node. If a child subtree has at least n/2 nodes, walk to it. Else, you're done. Is that the standard centroid finding algorithm? Let's first double check, because I don't actually know I don't know my graph theory well enough to just like be confident that this is true. But what is the definition of centroid again? Size of the largest connecting component of the remaining graph is the smallest possible. So if the child subtree is at least n/2 and you walk to it, that means basically that a centroid must lie in that subtree, right? Because how can it possibly be optimal? A centroid is always the largest connecting component after removing the centroid. Works because of the identity following true state. After removing the centroid from the tree, the largest connected is strictly less than n/2. And this is true because well, assume it isn't true, then you could have moved in the direction of the largest CC. Assume not true. Let largest CC be y and deleted centroid be x. Move along path x to y to x prime. X prime will be strictly better of a candidate than x. Maybe not strictly. Let me think about that. Let's just say weakly better. Because n minus CC size. New largest CC is bounded by max of this old CC size minus 1. Okay, so not a very it's not a very well written argument that I just made here, but I think it's rigorous. So I'm gonna continue now. Standard algorithms, yeah, I don't know. I just came up with this kind of, I've seen it before. You could probably find centroid finding tree centroid algorithm. It's probably on Wikipedia. It's probably everywhere. Centroid decomposition for beginners of a tree. Let's see. We probably know this person. Yo. This person, okay. Not a red coder. There's probably a tutorial somewhere from a red coder, but this seems pretty well written. And the DFS is, I don't really know what the algorithm is actually, but yeah, sorry, I don't have a great answer for where you find these standard algorithms. Bank Yusuko tutorial, he probably has something on this. Yusuko guide, view guide, search, centroid. Ah, here we go. This is probably a good Yeah, he's using the same algorithm. He's just looking to size and seeing if it's at least n over 2. If it is, then you recurse. And otherwise, you just return whatever you're at. So yeah, here's a good resource. Thanks for asking that question. Resource, paste it in chat. USCO guide, plug for USCO guide. Amazing resource for all levels, honestly. Yeah, here's centroid code. This is actually centroid decomposition, which is, an advanced technique that depends on a centroid finding algorithm, but, might as well just use this as a reference. It might be a bit advanced for you if you're just trying to learn how to find a centroid, but just focus on that implementation, I guess. Oh, and it links to more resources. That's amazing. So Galen Collin has one. Awesome. Anyway, back to the problem. I still haven't solved this yet. Spending too much time talking. But yeah. When is the centroid not unique? Well, this centroid algorithm will always yield, it's a deterministic algorithm if you pick a starting point. And the only case where it's not unique is when its parent is also a valid centroid. None of its children are going to be as good as it is, I'm pretty sure. Is that true? I take that back. I think the opposite is true. What do I think? Start log is really good. Igor Karpanese. Okay, yeah. It does look pretty good. But yeah, there are plenty of tutorials online for doing this stuff. But yeah, link cut centroids. I think what we can do here is probably something really simple, like moving a leaf around will always break the centroid thing, if it needs breaking at all. So output, yeah, you can just break an edge and then reconnect it if you want. There will never be 3 valid centroids. That just doesn't make sense. I think I need to wrap my head a bit more around centroids. Centroids are not intuitive to me. But sometimes you'll have 2 centroids, and that means they're connected by an edge, first of all. And then if you move one node around from one side of the tree to another, what does that look like? What does it mean? Sorry for going quiet. I think I solved the problem though. I think the two centroid case, we can kind of characterize it as follows. It's gonna look like you have two nodes. The two centroids are gonna be connected by an edge, and each side will have exactly n/2 nodes. Yeah. Because if one side has more than n/2, then, you know, it can't be a centroid. And if it's impossible for both sides to have less than n/2 because it's literally defined as such. So let's write this down. What does the two centroid tree look like? Exists an edge connecting a and x and y, so exactly half of the nodes are on each side of this edge. So for one, n is going to be even. And then how do you break a two centroid tree? Take an arbitrary leaf in x's subtree, move it to be a child of y. Leaf exists because n is greater than or equal to 4. And yeah, by moving it to a direct child of y, y's subtree now has n+1, and no matter which direction you move, you're going to lose at least 2 nodes. This breaks because y now has n+1 nodes in its side. Moving from y to any child will reduce size of CC by at least 2 because degree of y is at least 2, not including x. So yeah, y has at least 2 edges. If you move from y to anyone, you're losing y, and you're losing all of y's neighbors that aren't the one you moved to, which is at least 2 things. So proof is done. What does this mean for the implementation? Check each node. I guess what do we want to do? Root tree arbitrarily, compute subtree sizes, and check for subtree of size n/2, because it must exist. If exists, then move a leaf to its parent. If not exists, then no op. Move, cut edge, and restore edge. Okay. So what do we need to track? Represent tree in process of, okay, let's put it over here. Store par array. We're going to use 1 indexing or 0 indexing. 0 is root. Cut some edge and say 1 par 1 is a good edge to cut. And if exists, move a leaf to its parent. So how do we find this leaf? Find leaf by how do we find this leaf? You think it'd be easy. You think it would be easy. Doing an array leaf and setting leaf par x equals leaf x when processing a node. Do we have any guarantees about the order? No. Okay, this is post order, by the way. Pop. Do it after visiting all your children. Okay, so in our DFS at the end, after we've visited all our children, we're going to run this operation where we set leaf of parent x to be leaf of x. Initialize leaf x equals x. Okay, so then we're doing leaf centroid. And so we're cutting to par of leaf centroid, and then join leaf centroid par of centroid. Call it centroid. Okay, we're done. And let's just code this. I'm getting tired of planning. I don't have it all in my head because I've been talking too much, so I haven't been, really into flow of like holding a bunch of stuff in memory, spending too much time thinking about talking. But I think I got enough of it to be able to type it up. So let's just do it. Oh no, I need that. Alright, so root tree arbitrarily, read the tree, what is input, and edge list like this. And then DFS. DFS is we need par and leaf. So if next equals par cur, return, continue, par next equals cur, and rec next. Then we want to say leaf of par of cur equals leaf of cur, initialize leaf. And then read auto rec here. So that's our DFS. Then we also need sizes. Size n. Let's do it this way. Cur. And then size cur plus equals size next. And we can do this if size I is over 2. Let's do times 2 equals n to handle the odd case, centroid equals I. And then here we're going to say if centroid is -1, then we do a no op. Or, yeah, no op. And what was no op going to be? 1 par 1. So cut pair equals I 1 comma par 1, and join pair is the same one. Else cut pair is leaf centroid par leaf centroid, and join pair is leaf par centroid. Okay, and then we want to print out what we're cutting. Just cut pair.fi +1 and join pair. Great. And then we need to find these, run the code, DFS. Oh, it didn't like my DFS. Oh boy. Because I need to declare that it doesn't return anything, right? There we go. Okay. Let's run our code. So there's 2 test cases. The first one I say cut 2, which makes no sense. Yeah, that makes no sense. What's going on, man? So let's print everything out. So yeah, clearly my planning was not enough because my code didn't work the first time I ran it. But let's see what's going on. So centroid is -1 in both cases. My parent array is completely wrong. What is happening? Par of next equals cur. So this is not doing what it's supposed to do. What are these edges? So why is the parent array all incorrect? Because I'm DFSing on 0. Aha, I need to say par of 0 equals -1, don't I? I don't think that's the issue, but that can't help not having that. Okay, par is looking still incorrect. So par next equals cur. So let's cur next. Oh, I have self edges on x. Oh, there we go. It said B here, but it should be A. 6 2 6 1. Okay, 2 1 2 1. That looks much better. So the first one is exactly what they printed out. Second one, do I really need to check this? 6 2 6 1. It's probably right. Yeah. Okay. Let's just submit it. Okay, one final check. I think it's a good idea to do a final check after implementation. It shouldn't just be plan, type, submit. 10 to the 5. I didn't figure out anything. Okay, whatever. Let's just submit it. Stop. If it passes, I'm happy. Runtime error. What have I done? What have I done? I should run this with a more strict mode, I guess. I have index -1. How could it be? -1. Am I indexing on par somewhere? Aha, leaf of par cur equals leaf cur. Okay. Let's just resubmit that. That was a mistake, but fortunately it didn't cost us anything. Final time, 6:31. GT matters, check the edges. Yeah, thanks. I didn't see your message until, it was too late and I had already found the bug. But I somehow typed edb.pushback b. I thought I typed that correctly the first time around. I did YYPRB and then RA, but maybe I messed that up. My Vim skills, I trust my fingers a lot, so much that sometimes I don't look at what I'm writing. And in that case, it kind of bit me. It did not turn out all right. So I guess I should slow down a tiny bit. But yeah. Good thing it passed anyway. Let's move on to the next problem. What's the next problem? Problem D. I seem to be going through performance pressure. Yeah, let's just call it that. It must be that. This problem is actually not that easy. I'm surprised so many people solved it already. What's with the timer on the right? That's my implementation time. I'm measuring how long it takes for me to type up my solution after I've planned it out. 6 minutes for this. That's not a great performance, honestly. I could have done better. It is kind of a complex solution. If I hadn't made this bug, and if I hadn't made this bug, it would have probably been around 5 minutes, maybe 4, which would have been more acceptable. But I'm pretty happy with how I did my answer formatting, where I use a pair to store what I'm cutting and joining, so that I don't have to think about presentation twice. I only have to think about it once. And then centroid equals -1 is a pretty good way to put it as well. GT matters. Why red coders prefer Vim? You see many of them using Vim. Yeah, well, I can speak to why I prefer it. It's just I'm very used to it, and you can type really fast using Vim, basically. Like, I have hotkey to, like, insert line below. I have hotkey to, like, select a line and paste it, which is, like, I think faster when you don't have to hold command to do, like, command C, command V. And then there's, like, all kinds of tricks you can do to, like, navigate, which if you know Vim well, it's like you don't have to think about it. You just press the button and you know exactly where your cursor is going to jump. Like, if I want to jump to the P, I just type FP. Jump to the F, well, jump to the N, I just do FN, FN, FN. It's, like, very fast to navigate without using the mouse, but you can also use the mouse, which is even nicer. So yeah, that's why I like Vim. I imagine other people like it for similar reasons. Yeah, I have, like, syntax highlighting and checking, so, like, if I make a mistake in my syntax, I'll complain. I don't have to compile every time to find them. Alright, we're about an hour in. We still have the 2 hardest problems left, so let's just try to move on. Cowboy25, welcome to the stream. Hello. We are just getting started with problem D right now. 3 sequences. Let's open up our notes again. Full screening it, because it will probably be a lot of note taking. Okay. So, you have a sequence of n integers. You need to construct 2 more sequences of the same length, b and c, such that bi plus ci equals ai. Okay, so the sum of corresponding positions equals the original element. One is non-decreasing, one is non-increasing. I feel like I've seen this problem before. And then minimize max of all elements. And then you have to handle Q changes. What the? That I've not seen. The Qth change is a range increment. You increment a bunch of values of A. Am I getting trolled? This is a hard problem. So you print out Q plus more lines. Okay. And I shared a link in my notes. Sure. Just a sec. When I was a beginner, how did I make notes? I didn't really when I was a beginner. Here's a link to my notes that I have so far. Seems like my markdown is not really that neat yet, but whatever. But I think notes are useful. Definitely, I'm only doing it on my computer because I'm doing this for a stream. I would normally do pencil and paper or pen and paper. I think that helps me think. But yeah, I think note taking is good in general. Just write down the things that you want to remember when you're, solving the problem. Just write down things that you want to remember. Anyway, back to the problem. How do we solve this problem? I don't know. I don't know how to solve this problem. It feels like it's not always possible to construct these sequences. Like, oh no, your numbers can go as negative as they want. So it's actually not as hard as I thought. Anyway, the maximum number of all the sequences is either B0 or Cn. Max is either B0 or Cn minus 1. Numbers are allowed to be negative. And then I think from that point on, it's not too hard. I'm gonna take a bathroom break, and when I'm back, let's crush this problem. All right, I'm back. Yep, I finished reading the editorial, so I'm now ready to solve this problem. Just kidding. I would never do that. That's a good idea, though. I do have a lot of windows that I can open off stream. Okay. So I think a good thing to do right now is look at some samples. So 2 minus 1, 7, 3. The answer is, wait a sec. B is the one that's decreasing. Oh, non-decreasing. Aha, so that means I got it backwards. So B is increasing, C is decreasing. So let's work through a sample. 2, negative 1, 7, 3. So you want an increasing sequence and a decreasing sequence. M8, you're 87. Am I balding? No, I'm not. I just have a kind of strange hairstyle right now that isn't exactly the most flattering, and could look kind of balding. So yeah, yeah. If I take off my hairband, you'll see I have actually a ton of hair, so much that it gets in my eyes, which is why I wear a hairband. So why is the answer 5 here? That is not something that I understand at the moment. So I'm going to think about it. And mate, you're 87. It looks cool, not that you understand anything. Well, if you guys have questions about the problem statement, I'm happy to answer that. And then once I have the solution, trusting that I do eventually solve this problem, I'd be very happy to explain it in more detail. So yeah, my stream, the intent is for it to be somewhat educational, so feel free to ask any questions. Yeah, after becoming an LGM, then I'm allowed to lose my hair. But until then, I need to aggressively pursue my goal. And keep my hair until then. Okay, so why is 5 the best you can do? Increasing, decreasing. Increasing, decreasing. So what's with these mountains? Negative 1, 7, 3, 2, negative 1, 7. Let's first shift. No, we can't just shift it. Yeah, how does this work? Um, let's look at some more examples, I guess. 5. This is 3. Why is this 3? I don't see any reason why it should be 3. I am Faraz. Thank you for the compliment. A topic-wise stream, to just go in depth on one topic. I might make some YouTube videos like that. I also want to up my YouTube video count. So, yeah, DM me if you have suggestions on topics or post them in chat. I'd love to hear them. I'm trying to figure out where all these why the answers they're giving me are the answers. This problem seems much harder than the div 2D. I don't. I feel very slow. Okay. Silently think for 5 minutes. Okay, so I think I have a solution idea. Okay, so I'll write it down. I have 2 observations. Consider the deltas. So that means ai plus 1 minus ai. Let's call it like di. Positive delta means increase b by at least di. From bi to bi plus 1 must be. Optimal solution means increase by exactly di and hold ci constant. So we're thinking about this as we go from left to right, looking through the array A, we're going to just kind of gradually change either B or C every step to get us to the next value. And the optimal change is, only change one of them. You change it by exactly the amount you need, and which one you change depends on what direction you're changing it, because you're only allowed to increase B and you're only allowed to decrease C. So if you need to increase, you increase B, decrease, you decrease C. So that's like a pretty straightforward observation, that the deltas kind of imply which one you want to touch. Okay. So now the answer, which is max of C0 and Bn minus 1, can be expressed in terms of a variable x. And let's call x equals C0. Because Cn is just x plus sum of the negative deltas. And Bn is n minus 1, equals An minus 1 minus Cn minus 1, equals An minus 1 plus some neg minus x. Sorry, minus this. And this is a constant. So choose x to minimize max of x, and let's call it x, k minus x. Let k be the constant part. Now x is clearly best chosen as k over 2. And it has to be an integer, so floor it. And val is k plus 1 over 2. So I'm noticing that k probably needs to be a positive number, or else this doesn't make any sense. But it should be okay because A is all positive. No, okay, what? Do I have this right? I do have this right, I think. Just let me work out the details. Okay, yeah, the constant part should be pretty small. Yeah, sum of negative deltas is negative. And the last value of A is gonna be at most. Hold on, I don't know about that. What? Can the answer be negative? Of course it can be negative. Yeah, -1. Okay. I'm no longer confused. But I do have to be careful here about negative numbers. For example, if k is -1, do I want 0 to be an answer? If k is -3, do I want... Wait, if k is -2, the answer should be -1, but this will give me 0. So I have to be very careful. Seal of k over 2 about negative numbers. Okay. Use sine k times abs k plus 1 over 2 to compute CL k over 2. Okay. And 3, to handle queries. Sorry, I'll read the chat in a sec. We just need to maintain k, basically. K, sum pos, sum neg. Maintain this. Easy. Okay, chat, do you like Chief Keef? I don't know who that is. Problem statement has a typo, describing. That's kind of funny, describe. Could remix this. Stuck at 1500 to 1599. That's a very tight range, that's impressive. What would you suggest me do? Yeah, some other people in the chat have suggested practicing problems that are higher than your rating by at least 300. Yeah, work on your weak topics. I would say just review the problems that you didn't solve. Make sure you understand why you didn't solve them. And then make sure that next time you see a similar problem, you can solve it. Just like think deeply about the topics that you don't understand. Make a lot of diagrams. Look at it from different angles, and try to just really master all the concepts that you know you're weak on. I think most of the times in code forces, people know the different topics that exist. They just haven't mastered them, and that's why they don't solve the problems. It's not that they haven't heard of like dynamic programming. It's just that you might not have mastered dynamic programming yet. Okay, so implementation notes. Now that we've gotten our solution note, we only have 45 minutes. Okay, I gotta hurry up. So remember that k is a minus 1 minus some neg. Some neg gets updated okay, so decompose the operation inc lrx to inc, this is just two operations, so d sub l plus equals x, d sub r minus equals x. To handle changing di from old val to new val, do old val minus 1, new val 1, inc x, if x less than 0, sum neg plus equals x times sign. So this is the key line of code that's going to be useful, I think, which is we first decompose the operations into two independent operations. We're updating the deltas for L and R. And let's clarify that L and R are half-open ranges. Oh, this is R minus 1. Okay. 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 So this is how we maintain some neg, then evaluate k, seal of k over 2, print yes. So that's the easy part. Let's do it. Maybe we should do this just one walkthrough of the input to illustrate the actual algorithm as a sanity check. So let's do running our solution on the sample. So after the initial read, sum neg equals -3 plus -4 equals -7. And then a sub n minus 1 equals 3. So k equals 10. X equals 5. Okay. Yeah, because remember k is 3 minus 7. Yeah. And then after incrementing 2, 4, negative 3, so remember this is LRX, let's first L equals 1, R equals 3, but then R equals 4 because of the inclusive endpoints. So some neg changes by updating D0 and D3. D0 goes from negative 3 to negative 6. And then D sub 3 goes from negative 4 to negative 1. Some neg is actually still negative 7 and still 5. Cool. GT matters, I'm a specialist. Yeah, I mean, I think all the practice strategies are pretty much the same. Just work on the stuff you're bad at. Like, look for tutorials, I guess, but also just think about it a lot. Think about the math, prove things. If you can prove things rigorously, then you'll understand it better. Okay, final update is L equals 2, R equals 3. So some neg changes by updating D sub 1 and D sub 2. D1 goes from 8 to 6, no, 10. And D2 goes from negative 1 to negative 3. So now k equals negative 9. Oh, hold on. I made a mistake. A n minus 1 is now 0. Why is the answer still 5? It should be 4. Oh, it's because we're not actually... There's no such thing as D3. So, D3 doesn't exist. Ignore. So, some neg actually changes to 10. K is still 10. Okay, so that was a bit tricky. Hey Bubba Smollett, welcome to the stream. When do I usually stream? I'm gonna try to set a pretty regular schedule. I haven't streamed in a while. This is my first time in a while. But I'm planning to do something like 5 hours a week, maybe more eventually. And around 8 p.m. Pacific time is when I get off work. So on weekdays, it probably won't be before then. I'll try to post a schedule on Twitch/Codeforces, and that should help you all if you're trying to not miss my streams. Conjure Rub 7. Do I write implementation notes during contests? Yes, certainly. I definitely do. I write it on paper, not on my computer usually. And the kind of notes I take are kind of what you're seeing here, just the key mathematical like equations, the variables that I need to maintain, the definitions of various things. I try to come up with names for my key variables ahead of time, things that will be used multiple times throughout the program, because that really helps me like solidify the concepts in my head and avoid making mistakes when writing my code. Anyway, I don't want to go through this example anymore. I think I get it. So I just have to remember to track a(n)-1 as well. All right, let's just get to it. We'll give this a name because we'll track it separately. Reset. Okay, one last question. Shri E, how to improve algorithms? I'm seriously in trouble with graphs. Last contest, random bipartite graph implementation. Well, what? Yeah, graph theory is hard. Just think about graphs a lot. Like, really master your fundamentals, DFS, BFS, all the shortest path algorithms, really understand them deeply, then go into like union find, understand like how coloring works, all the standard graph theory stuff. It's like usecode.guide probably has a great section on it. But yeah, things like graph theory and combinatorics, really think about it deeply in your head and on paper, write out examples, get a lot of intuition for how these objects work. All right, we're going to start coding this. My target is going to be 5 minutes. It probably isn't going to happen because my head's a bit fuzzy, but we'll try our best. Okay, I typed a bunch of stuff. Should maximize this because I need to read my code. Last, I'm not handling yet, so I'm gonna say if r equals n last plus equals x. And then let's do this. So let's try it. Let's see if it works. Oh, sign v, update v. Okay, that's okay. Nope. Subscript for elements. What's going on? Could it be that L is too big? No. Could it be that R is too big? What is 4 elements? Aha, it's over here. N minus 1. 556. That's correct. Am I using a tiling manager? I use Spectacle. 3331. 00-1. Submit. Let's double check. Do I have any ints that shouldn't be ints? Int last. That should be long. That's a good catch, Steven. Int LRX. That's fine. D is a long. Yep, okay. So that last catch we made, setting last to be a long was actually pretty significant. Without that, I think this would have failed. This still might fail, obviously, but pause. Exactly 5 minutes. But it's gonna pass. Please pass. This will be my first time passing today. No, I got a wrong answer on test 3. Yeah, for all my talk about planning my implementation to avoid bugs, I've been getting a lot of bugs. Yeah, F's in the chat. Yeah, I don't think this is the right logic. I said I needed to be careful about taking the ceiling of a negative number divided by 2, and I wasn't careful. What I actually have to do here is +1, I think. No, I just do k over 2, huh? That is as simple as it gets. I should have done the thing where I take the sign, but I don't have sign as a helper function. So that's why I didn't. But I honestly shouldn't have made this mistake. The ceiling of a negative number divided by 2 is just k over 2. So let's just write down our total time. Right around 5:15, let's say, and 1 wrong answer on test 3. Learnings, the bug was ceil of x k over 2 was computed incorrectly for negative k. Formula is k over 2, but I wrote k minus 1 over 2. Learnings, don't deviate from implementation plan. Because I literally sine k times abs k plus 1 over 2 is safer. Just write sine equals to x return. Yeah, just write this next time. Okay. I'm kind of dumb for like the most recent problem I solved. I got it wrong because I deviated from my implementation plan. And then the very next thing I did was deviate from my implementation plan. You can tell, although I know what I need to do, I don't always do it. It's really just a matter of discipline at this point. I rushed again. I blame it on the nerves because I'm streaming. But we all know that in the actual contest, I still get a lot of wrong answers. So I am learning valuable lessons about discipline. I'm going to take a bathroom break, and then we'll crush this last problem. Alright. If anyone here is just tuning in or missed the intro, I'll do a final recap of what's going on. I'm doing a virtual contest, a Division 2, round 670, and the way I'm doing it is for every problem, I'm going to read it, take notes, try to come up with a solution, and then here's the important part. I'm going to plan out my implementation as much as I feel like I need, and then when I go to start typing, I'm going to use the stopwatch here on the upper right hand corner of my screen to time how long it takes for me to churn out all the code. And the strategy here, of course, is to plan it out very comprehensively to minimize the amount of thinking and pausing I have to do during the typing part. So this is to encourage myself to just spend a lot of time planning before typing, because I have a bad habit, and this is a thing a lot of, intermediate advanced coders even have, which is just they start typing too early. Maybe they have 70% of a solution in their head, and they just start typing. My belief is that when you have 95% of a solution ready, that's the right time to type. It's actually going to save you time in the long run if you do it that way. Oh, and sine k abs k plus 1 over 2 looks wrong. Wouldn't seal negative. Oh, you're right. Oh my god. So even if I had followed my plan, I would have been wrong, huh? I just can't win. I just can't win. Sealing of x over 2, who knew it would be so hard? Next time, is there anything I can do? Okay. Thanks to Enson pointing out that this is actually still wrong. Yeah, Opus Sensei, thanks for tuning in. Yeah, so learnings are dividing an integer by 2 is extremely difficult. Never forget. Okay. Yeah, Enson, really good catch. I'm glad that someone is paying attention. I'm actually very impressed. I was totally convinced that the sine abs thing would have worked, but you're right, it doesn't work. So yeah, the recommended way to divide and seal is x greater than 0, x plus 1 over 2. Otherwise, just x over 2. Anyway, let's get started on problem E. The last problem of the day. Interactive problem, my favorite. Unknown integer x, n is up to 10 to the 5. You need to find it. And then you have 10,000 operations. And you want to count multiples of, you can query at number A to find how many multiples. Delete all multiples, but x can't be deleted. And then C is just guess the answer. Very interesting. So this feels like kind of a prime sieve, but what do you do when there's a bunch of primes? How many primes are there? I think prime pi tells you how many primes there are under n, right? That's what pi means, number of primes less than or equal to x, and it's just under 10,000. So let's note that. Cool. So that's a good hint that it's related to prime numbers, but that shouldn't be surprising. So find how many multiples of A in the current set. And then we still have 400 more queries. So what do we do with those 400 queries? I think we can, like, if we could just do every operation twice, that would be easy peasy. Because then, in the first pass, we delete all the numbers except for x, and in the second pass, we'll find all the prime factors. Oh, prime factors isn't enough. Huh. Well, we can probably throw in all the prime powers. Throw in all the prime powers. Just cause that will be fine. So how do we make it so that after a while we just have the answer? Let's consider what is prime pi square root. I think it might be small enough, so let's just do this. 65, what the? That is very small. So we can afford to check those twice. I think a solution is coming together. So what is the solution? I think the hard part is, like, what if they just say x is going to be a prime larger than square root n? What do we do then? If it's a prime greater than square root n, oh, you can query a equals 1. Oh, important. I didn't realize you could do that. Okay. Query a1 to count size of set. Very important operation. I think this is enough to solve the problem. Queries a1 and a prime power, or b prime power. Maybe we can query a1 every, like, square root, every 100 operations, maybe? Because we have 100 operations to spare. And then once we find that, oh wait, some number is still there that was supposed to be deleted, that will narrow it down a lot, basically. M8, you're 8-7. Do I watch anime? Occasionally. I don't watch too much anime. Okay, I haven't quite strung together a solution, and we have 19 minutes left, so I really need to hurry up here. If x is prime, how many queries it need? I mean, that is the hard case, I think, is if x is prime. I think I'm going to start by querying B on all primes less than root n. And that will tell me if x is a large prime or not. And let's try to solve the not case. Let's say we know that x is a multiple of one of these. Then we can immediately... we can't quite yet jump to any conclusions about the large primes yet. But now query ax for all prime powers x. And that will tell us the prime factorization of x. So we're querying all prime powers. So if x is greater than square root n and it's prime, can we do something similar? I think we have to use a of 1 here to kind of okay, can we use like binary search even? Like let's say we query B of all the primes, the first half of the primes, and query A1. That will tell us if we got it or not. And if we didn't, then we keep going. If we did, then we narrow down the search. Yeah, no, we don't want to query A1 in the very beginning. We query it after doing a bunch of B operations to know if one of the B operations had an effect. So let me write this down. Solution. Start by determining whether x is a large prime or not a large prime. So we'll define large prime p greater than square root n. Not a large prime. Prime factorization is wait, why does this matter again? Why do I need to do it this way? I just do. At least one prime factor less than square root n. And yeah, we basically want to query A1 every few hundred B queries. That is exactly the strategy here. Do this by querying B of P for all P less than square root n. So yeah, start by querying all the small primes, then query A1. If the answer is exactly number of large primes, then that means x is large prime. Else, x is small prime. Or small prime is not. Okay. So 2 cases now. Hey Absheka, thanks for the support. And everyone else in chat. Yeah, why do we query A1? It's to check if any of our B queries were effective. Mr. Yushi, case where x equals large prime times small prime is solved. Yeah, those cases we just treat as like not a large prime. the important thing is basically like if x has a small factor, then we'll be able to detect x by querying a factor of it, and we'll be able to tell that it's a factor of x because we'll be able to count this multiples of like p, and we'll see, hey, there's one more than we expected. That must mean p is a factor of x. Factorizable. So let's say not a large prime. Then for every prime power p to the I, let's call y equals p to the I, query a of y. At this point, all multiples of y should have been nuked already. So, from earlier call to b of p. So if a of y is 1, that means y divides x. So multiply together p for all y. And this gives you x. And then that is how we solve that case. If x is a large prime, then run BP for all p, but check A1 every now and then to see if it's number large primes or number large primes minus 1. If it is number large primes minus 1, or sorry, remaining plus 1. How much time do we have? Okay, we have 10 minutes. We can implement this. Yeah, we check if it's either the number of remaining large primes or the remaining large primes plus 1. That one of the most recent B operations did not delete anything. That is X. So check all of them. Okay. So how do we implement this? How do we implement this? And let's do a quick check that the number of operations this uses is okay. So phase 1 and phase 2. And let's analyze how much the cost is. So this takes 65 operations because prime pi is 65. Phase 2, 2a, will query all the prime powers, including the large primes. So it takes around 9592. And here it takes around 9600 plus like 100 plus 100. Okay, and that's also okay. That's barely okay. And implementation notes. Let's have 3 functions. Phase 1, phase 2, phase 3. This is int, this is int, this is bool. What happened? What happened? Oh, this is bool. True if phase 3, false, false. Okay. And then the interaction helper functions, query A, int query B. Do I need B to return anything? I don't think so. I'm not using B as a query, right? It's just an operation that I don't care about the answer from. That's very nice. Time is ticking, yeah. Let's get started. I might not be able to finish this in time, but let's see. This will require very precise coding from me. And then I need to do a prime sieve and prime powers. And let's write some key key vectors, key variables, because I need to have my large primes. Yeah. All right, let's go. Let's rearrange this a bit so I can see my notes while coding. So I need to print A and L. Okay. And then n, and then let's have vector int small primes or large primes and all prime powers. Sieve let's do it this way. So I times I less than equal to n, then greater than n, large times dot back I, and then while j is n, all prime powers j plus I. Okay. And then phase 1, bool. We're gonna, how much time do I have? I'm gonna run out of time, aren't I? 4 minutes. Query B for all small primes. So, oh, so maybe I need small primes as well. So int p of small primes, query b p, and query a 1. And if it is exactly the number of large primes, then that means x is a large prime. So we'll just return this. Cool. Phase 2. Int. Now we have to do this thing where we, for every prime power, I, all prime. Let's just do it all primes. And we'll do this logic here. Oh, I forgot to sieve, huh? Okay. So while j is less than or equal to I, query a, j, and if this is equal to 1, then amps times equal to I, and then return amps. And out of phase 3, and here we're just going to do if phase 1 amps equals phase 3, else x equals phase 2, and query c amps. Okay, final part. We have 1 minute 30 left. I haven't compiled my code at all, so this is gonna be dicey. Phase 2, phase 3, run BP for all p, but check a1 every now and then. Oh, recent for int I large primes. So query bi if recent if size of recent is at least 100, then recent dot clear query a1 oh my god, remaining equals large primes. Remaining this is not gonna work, huh? If query a is greater than remaining, that means we found it. Then j recent if query a j equals 1, return j recent not clear -1. Submit. This is not gonna work, is it? 30 seconds, no time to run it. Yeah, I ran out of time. There's no way this is passing, but at least we had fun. I'll probably try to upsolve this if this, when this inevitably fails. Wrong answer on test 1. Yeah, I didn't time manage very well. I do think I got most of it written. You can't see any activity on the screen. Oh, I'm sorry. It wasn't correct in the end. I wrote all the code that I wanted to write, but I didn't have time to test it, and I must have made a mistake somewhere. So let's see. Oh, am I just printing out things but not reading anything? Well, that explains it. Yeah, that was kind of bad, but A1 after querying 2 and 3, what's left is 5 and 7. So 2. Am I pretending that answer is 5? Oh, well, it's incorrect. Oh, because it needs to do this at the very end. Or remaining equals 0. Okay, so let's resubmit and see if this would have passed. If we had like 1 extra or 2 extra minutes. It's still a wrong answer. Yeah, let's see what's going on. I don't want to debug this in a contest environment anymore. I feel like I solved the problem. I kind of know the gist of it. Let's just see what I'm doing. Integer parameter violates the range 1. What does that mean? Am I somehow printing out 140? Yikes. That's some product of 4, 5, and 7. Yikes. Is it cheating if I live stream competition? Yeah, this isn't a real competition. This was just for practice. This happened like a month ago. The live competition. It would be cheating if it were for real. So yeah, it seems like my program was just completely wrong. Let's try to debug this. That mad dash at the end was, yeah, not conducive to writing good code. So sample case 1 had, oh, maybe query B is out of range. Yeah, that's possible. Is that what it's saying? Name equals A. So I'm querying A on something that I shouldn't be querying. So where am I querying everything? Query A, J, recent. It's mostly just large primes, I, but I is always less than n, right? Yeah, I don't know where 140 is coming. Maybe it's saying that my answer is too big. That is totally plausible. So let's print out my answer. And what is the judge saying here? Or what was the problem? Opa Sensei, can you explain how to do any query problem? I don't have any idea. Interactive problems are always kind of tricky. They are just like, they define the game, and you have to like just think about how you can use every query to give yourself the answers you need. You have to kind of figure out what kind of questions am I allowed to ask, and how should I ask them so that I can answer the final question that they're asking. That was not a very good explanation, sorry. So the answer here is 4. So B2, okay, got it. A1, so at this point, oh, there's also 1. I forgot about the number 1. So A1, there's my issue. There's my issue. 1 never gets deleted. I forgot about 1. So there's 1, 5, and 7 right now. So that's 3 numbers. Oh, and 4. So I want to say 1, 5, 7, 4. That's 4 numbers. And then it'll be in phase 2. And I'll say 1 here. I'll say 1 here. I'll say 0 here. 0, 0, 0, 0. Okay. Now if I resubmit, it's gotta pass. I'm so confident that I fixed my bug. I'm just gonna submit it again. So yeah, the logical error. Let's fill out my notes. Oh no, it's still wrong. It really doesn't like what I'm doing here. Oh, I see. Expected. Yeah, it's because 5 and 7 actually do give answers. Or they actually do still have A will give you 1 because they themselves have not been deleted yet. So I should have fleshed that out a bit more in my notes. Where are my notes? Running on test 2, running on test 4. Oh, Jesus. What am I doing wrong? It's still printing out really big numbers. That's concerning. It's concerning. Why might it be printing out such large numbers? Can I factorize this? So 5081 is somehow being included. Yeah, I think I'm just gonna end the stream if I don't solve this in the next like 5 minutes, because honestly, I don't expect to be able to. I wrote this kind of too fast, so a lot of the I guess decisions I made on the fly were probably not very good decisions. Like this stuff, I think it works, but I wasn't thinking about it very hard. I mean, this does kind of make sense, honestly. Maybe it's phase 2 that's wrong then, because this is not a prime power. So I already deleted all the small primes, so that includes 2. So this should be gone. So when I go to do this, why am I even querying? So I'm doing okay on primes. I'm just failing on these numbers. So I'm probably multiplying a bunch of numbers that I shouldn't be multiplying together. Ans times equals I, j times equals I, query j expected plus plus expected if it's a large prime. That is how I'm defining large prime. And then, this needs to be LL. Yeah, so another just implementation mistake. I wrote int and then I multiplied it by itself, which is just a bad idea. So I should probably check my code for other instances of ints. Vector int recent. Where am I doing multiplication? Anywhere? I'm multiplying I by itself again. Okay. And then ants is a long. Why is it running on test 1 forever now? Alright, as soon as this test finishes running, I'll know if my code is correct or not. Regardless, I think I'm done for tonight. Please let me know if there's anything you guys want to see. Well, I guess I could look at my standings, see my final placement. It was not very good because I got 335th. Even if I had solved the last problem, my placement would not have been amazing. Idleness limit exceeded on test 1. What did I change? Wait, what? Wait, this is a very different problem. What did I just do? I accidentally CD'd out of my code. I submitted the wrong file. Have I ever gone first? No, I don't think so. You can see my I've passed contests. Okay, wrong answer on test 10. I'm making progress very slowly. Let's see what it is now. When the answer is 1, of course, I am not handling that case correctly. Why did I think I was? So that's another edge case I didn't think about. So 1 would go into, it would go into phase 3, at which point I should just return 1 at the end, of course. So now I'm pretty sure I got all the cases. That was a hard problem, but please just let me pass, Mike Merzanioff. I'm begging you. Okay, so it took me 12 extra minutes to debug, 14 extra minutes to debug by trial and error. So final time, a lot more than I was hoping for. 5 mins initial implementation, additional 14 mins trial error debugging. I blame it on not planning it out ahead of time enough. But yeah, M8 Year 87, your question. Have I ever gotten first? Here's my recent contests. As you can see, these numbers are usually in the double digits, if not triple. Very few of them are close to 1. I think my best results are like 8th place in recent times. Maybe long ago I got higher than that. Like I got a 3rd place at some point. This was probably the highlight of my programming career. Click on this. Yeah, a few like 6ths. Wow, I used to be pretty good, huh? I got 6th place in one of these contests. But yeah, and then in Division 2 I got like 12th place once, I guess. But nope, never got first. How old was I? In 2014? I think it was around 18. So this is back in my glory days when I was a top player. 4th place as a purple coder. That's pretty good. I had a lot of variance in my performance, I guess. Yeah. These were the days, man. Back when I could get 3rd place in a contest on Codeforces. No longer. But yeah, we finally passed this Div2E. It's a hard problem. It definitely requires enumerating the edge cases ahead of time, or else there's no way to come up with them on the fly if you didn't come up with them while thinking about the problem. So yeah, given another 10 minutes, I would have been comfortably able to solve this problem. The bugs of, what do I return here, I wouldn't have made, because I just guessed. I wouldn't have forgotten about number 1, which caused most of my bugs, and I wouldn't have carelessly multiplied an integer by itself. But yeah, that's it for today. Catch me next time. This has been a pretty long session, so I'm kind of tired. I'll answer, I guess, like a few more questions that come in, but apart from that, see you all next time, probably sometime over the weekend. When did I seriously start training? It was my freshman year of high school, I guess. I was doing Yusuko. I had a lot of friends who were also doing it, so they kind of gave me advice on how to get started. Alright, see you ever next time.